Welcome back to Math 171 Pre-Calculus Algebra. In this video, we're going to take a look at some of the different types of variation that we have, and then things that you can do with that. So the two main types of variation that we have are direct variation, which will usually be indicated with y equals kx. But this would be written as y varies directly as x. Or sometimes you'll see it written y varies directly with x. So the big thing here is we have y equals kx. And sometimes you'll also see this done with powers, so like you could see y varies as the square of x. Well, then you're just getting y equals kx squared. Other main type of variation that we have is inverse variation. Which is going to be y equals k divided by x. And this one would be written as y varies inversely as x. I guess another one that you will see on occasion is proportional. So up here you might see directly proportional to. Down here you might see directly proportional or inversely proportional to. But then, as you can probably guess, in the real world, we are going to have some combined situations. So combined variation, the real basic ones, you just have to read each one. So it might say directly with something and then inversely with something else. But the one special one that we want to talk about, and in the interest of time in this video, I am not going to write this problem out. But instead, I'm going to go ahead and type the problem in the description of this video. Now, the problem is the centrifugal force C of a body moving in a circle varies jointly with the radius of the circular path and the body's mass, and inversely with the square of the time it takes to move about one full circle. A 6-gram body moving in a circle with a radius of 100 centimeters at a rate of 1 revolution in 2 seconds has a centrifugal force of 6,000 dynes. Find the centrifugal force of an 18-gram body moving in a circle with radius 100 centimeters at a rate of 1 revolution in 3 seconds. So this is really going to combine everything that you have for this chapter together, but we do have the term in there at the beginning where it says varies jointly. So what that literally means is it varies with the product of the two things. So we know centrifugal force, which we're going to call C, varies jointly with R, the radius, and M, the mass. So we have K times R and M. And inversely with the square of the time it takes to move one full circle. So T squared. And we're given that we get 6,000 dynes. K is the first thing we need to figure out, but we're given that we have a radius of 100 centimeters, and it's a 6-gram body, that we turn one revolution in 2 seconds. So I can go ahead and simplify the right-hand side here, and I get 6,000 is equal to 150 times K, and then I can divide both sides by 150. I get 40 is equal to K. Well, that tells me that the actual formula for centrifugal force is C is equal to 40 Rm over T squared. And now, to solve the problem for an 18-gram body moving in a circle with radius of 100 centimeters at a rate of 1 revolution per 3 seconds, I just need to plug my numbers in. So my radius is 100. My mass is 18. And my time is 3. And if I punch that into the calculator, it turns out that equals 8,000. So we get the centrifugal force as 8,000 dynes. So that concludes, there's actually only the one video today. So that concludes that, and it also concludes Module 3 of this course. I will have the test becoming available to you on Thursday. However, because spring break is coming, the test for this module is not going to be due until the Sunday right before we return from spring break. So you've got plenty of time for the module test. And then when we return from spring break, we'll start talking about exponential and logarithmic functions.